Okay, welcome back to video 2. So in video 1 you saw GCF. We're going to look at two problems for a new type of factoring called factoring by grouping. And factoring by grouping, there's a really nice signal that tells us that factoring by grouping is the best method to solve that problem. You're probably noticing when you're looking at the problem that it looks a little unfamiliar. So we use this method with 4 or more terms. Generally, we'll only really see 4, but if you have something with like 5 or 6 terms, like something crazy, you could use grouping for that as well. But generally, like I said, it's going to be if you see 4 terms, that's your cue. I just don't want to say that you can't do it for more than 4, because technically you can. So I'm going to show you guys in the first one, I'm going to kind of walk you through, and then by the second one, we'll talk about, maybe like you trying the setup on your own and pausing the video as you're getting used to it. So the first step of this is to group that into 2 pairs. So step 1 is we make 2 pairs. And generally it's the first 2 and the second 2. So we make 2 pairs, right? Or 2 groups, right? Grouping. And then the second one is we're going to find the GCF of each group. So when I look at my first pair, they don't both have numbers, but they both have x's. They both have 2 x's, so I'm going to pull out an x squared. X squared times an x would be an x cubed, and x squared times 7 would be a 7x squared. I'm going to pull out a 5 from the second one, because I'm seeing a 5 goes into 5 and 35. So 5 times 7 would be 35. So at this point, I've pulled out my GCF, right? I've got GCFs in front. Now what's really cool is notice this and this are matching. Now I want you to think about what would you do, I'm going to write something different, if I told you to take x squared times green box plus 5, and I'll try and color code it, times green box. If I asked you to factor that, think about what would you do. Think about our last video, our GCF video. You would probably say, well, I could take the box out as a greatest common factor. It looks a little weird. And then say that it's box times x squared plus 5, right? If I was to distribute, I would be back to where I started. So we're actually going to do that same idea, except for instead of just a box, it's going to be an x minus 7. That's kind of like your box. And that was the greatest common factor. So I take that out and I put whatever's left. Notice if I was to distribute the x minus 7 times x squared and the x minus 7 times 5, I would be back to where I start. So the GCF, like the bigger GCF that we pull out, is the x minus 7. So that's why I intentionally wanted to make sure we felt really good by watching the GCF video first, because it really builds nicely into this new type of factoring by grouping. And then just like we saw in the last video, we want to double check, is there anything else we can do? X minus 7 is as simplified as we can go. X squared minus 5, that kind of makes me think of a difference of squares, but a difference of squares needs subtraction, and 5 is not a perfect square, so that's all we can do. So that is my final answer. Okay. In the next one, you're going to want to try and think through it a little bit independently, right? You're going to want to try and test how your understanding is going. But we're going to walk through it a little bit more because this one has some bigger numbers, and we haven't seen bigger numbers. One thing I want to point out before I move on is the fact that these are matching. That's how you know that you have simplified it correctly. We want to get the 2 pieces to match so that we can take out a GCF. So we're going to use that idea as we look at this next one. If I do the same first step and I make my 2 groups. Now this one's a little tricky with the minus sign. I'm going to give you guys the advice to group it with the minus sign, kind of put like a little plus in between there. It makes it a bit easier to do. And so I might say, okay, well, a GCF, let's see, I know that 18 has a lot of things that go into it. I know 45 is 9 and 5. I know that 18 is 9 and 2. So let's try and take out that 9 maybe. Let's try and take that out as a GCF first. So we'll take out a 9, and there's 2 x's in one and 3 in the other, so we can only take out 2. And then I'll have, let's see, 9 times 2. And then I'll have 1x left. 9 times 5 is 45. And then I'll have no x's, because 5 times 9x squared would be negative 45x squared. So now here's the thing. I want to see a 2x minus 5 in both places, right? Up here we saw the x minus 7 in both. So the trick is I want to get it to turn into a 2x minus 5. So how do I make an 8 turn into a 2x? I know it's divisible by 4. So if I take out that negative 4, I want to kind of color code it. If I take out that negative 4, and leave it as 2x, right? Negative 4 times 2x would give me that negative 8x. And then negative 4 times a negative 5 is equal to 20. So notice by grouping that negative sign, it makes us really want to take it out. If I had only taken out a 4, it would have been a 4 times negative 2x plus 5. And then your signs would have been off. So generally the rule of thumb is if you take out a GCF of a negative number, it does actually make it a little bit easier, which is kind of strange, but that's kind of how it works out in most problems. So now I'm seeing that bigger GCF of 2x minus 5, right? And then what's left over? I've got 9x squared minus 4, right? And if I were to redistribute the 2x minus 5, then it would be, sorry about that, guys. I'm getting a spam call, looks like. There we go. If I was to redistribute the 2x minus 5 to both pieces, then it would be back to where I started. Now, the last thing I want us to do is think about, are we done? The first one, we looked at each piece and we said, yep, there's nothing else I can do. But kind of lean in on this guy here. Maybe pause the video and try and think, can I simplify that and factor it any further? So go ahead and pause and think. Unpause when you're ready to kind of hear about it. So you can actually factor that further. We would factor that as a difference of squares. So I'm thinking about what times itself is 9x squared. It'd be a 3x and a 3x. And then I know a 2 and a 2 makes a 4. And remember, we need a plus and a minus if you want to double check using an area model. Right? 3x times 3x is 9x squared. 2 and negative 2 makes negative 4. Then you've got a 6x and a negative 6x. Notice those are going to cancel out. So a lot of people will use the trick for a difference of squares that we talked about yesterday, like a plus b times a minus b is equal to a squared minus b squared. So they'll just kind of square root both pieces, like the square root of 9x squared is 3x, square root of 4 is 2, and so they'll just kind of set it up with the plus and the minus. Okay, so just keep that in mind if you want that as a shortcut, that is available. And that would be our final answer. Nice job, guys. So on Thursday in class, we're going to do some practice with our GCFs as well as our grouping. See you then.